Hello, everyone, and welcome to RC Plane Lab. I'm Ron.
I'm Tom.
Today, we're going to be talking about a continuation of last week's episode. This is how to set up your landing gear.
Yeah.
Before we get into that, a couple things really quick. Don't forget, once again, we still have a news survey on the website. Go fill it out if you haven't already. If you have, thank you very much. And we're taking May off. Don't forget about that. No new episodes in May. Coming back in June, we will be going to a once every 2 week release. And then once fall hits, fall/winter sometime in there.
Once the flying season is over.
We'll resume our weekly release.
Yeah.
And that's just to give us some time to, go outside and do some stuff and not be tied to this. As much as we enjoy it, we have other things that we ought to be doing also.
Yep. Yeah, so we'll resume the normal schedule there after the flying season's over. And hopefully by then you've all filled out the survey and given us plenty of material to talk about.
Plenty to talk about. And hopefully we'll have enough done to where we can talk about that too. So.
Yeah, that'd be awesome.
Okay, let's talk about setting up our landing gear.
Okay.
First,
all right.
Wheels.
Yeah, we didn't really touch on this in the episode before this one. So I just thought I'd put together a few tips for mounting your wheels onto your axles. You're going to use you don't want any. You want your wheels to spin freely. You don't want any binding of the wheel or anything like that. And sometimes binding can be caused by the wheel actually contacting the strut,
but not too freely.
No,
you don't want them to be. I mean, you want them to spin freely, but you don't want them to be so loose fitting that they jerk around, or do you know what I'm trying to say?
No, not actually. I don't.
Like if you use a wheel that's too big for the axle that you have.
Oh yeah, it's wobbly.
It's wonky. I guess is your word.
It introduces wonky ground handling.
It introduces wonk. And nobody likes to have too much wonk.
Nobody wants wonk. Nope.
No, so loose is good, too loose is bad.
Yeah, exactly.
That's all I was trying to go for.
Okay, well, it makes sense. But yeah, you don't want any binding for sure. Like I said, sometimes binding can be caused by the wheel actually moving too far in on the axle and rubbing the strut. And to fix that, you just basically shim the wheel away from the strut on the axle. And you can do that with wheel collars, washers, spacers, shim, whatever you have handy to shim that wheel away from the strut is going to do you pay dividends by nice, smooth ground handling.
The last thing you want is an accidental braking on a wheel.
Yeah. Because
then you turn or then you flip over.
Yeah. You definitely do not want an uncommanded turn on your takeoff run. That is bad, and that could be caused by binding of the wheel. And the most common bind I see is the wheel just going too far in on the axle and rubbing up against the strut. So that's one quick tip. Yeah, make sure the wheel is not touching the strut, and then you want the wheels to spin freely, but you don't want them to spin too freely. So what I find I sometimes have to do is sometimes the wheel I want to use doesn't fit the axle that I have available to use. So sometimes I might have to drill the hub of the wheel out, and that's fine. It's totally okay to do that as long as the material is there for you to do. Just don't drill it out too big, otherwise you get a wobbly wheel, and you don't want that.
Wonky wheel.
Yep. And if the hole in the wheel is too big for the axle that you're using, sometimes you can shim that hole using aluminum tube or brass tube or whatever you can find to shim that hole size down. And sometimes you can even do the same thing by filling the hole with epoxy and then re-drilling the hole. I've done that before too.
Really?
Works like a champ.
That seems like it would be a pain.
It's not easy, but I mean, if that's all you got to work with, then yeah, I've done it. It's not hard to do, especially with the Dubro, the plastic style wheels. It's a piece of cake. And essentially what you're doing, by the time you drill out the hole again, you've just got a perfect size shim inside the hole. I mean, you're not counting on the epoxy to do anything structural. It's just taking up space.
Well, and like how exact, like obviously these don't get balanced. It's not that big of a deal because you're not going that fast. But how close do you need to be? Because I would think trying to re-drill a hole in the middle of a wheel, like finding the exact center, would be a little difficult.
So there's a trick to that. When I fill a hole up with epoxy, I don't I fill it as close to fully as possible, but I'll leave a little bit at the top, a little space at the top. And usually what will happen is as the epoxy cures, it'll kind of form a divot, and that divot is perfect for centering your drill bit in the hole.
Oh, that's a good idea.
Yeah.
I'm glad we have these conversations.
But yeah, but to be honest, I'm sure I've not drilled them perfectly in the center. And for sport type airplanes, it's fine. If you're building a big high dollar scale warbird kind of a thing, chances are you're not going to be using plastic Dubro wheels on it that don't fit your axles. You know what I'm saying? So, but yeah, in a pinch, I've filled the holes before and re-drilled them.
Cool.
And it works perfect. Another tip, if you're using wheel collars have set screws that actually attach them or anchor them to the axle or the piece of wire that is being used as your axle. Do yourself a favor and file a flat spot on that axle wherever that set screw is going to contact the axle. That's just one more insurance policy you can take out to keep those collars from spinning off of the axle. If you provide a nice flat spot for that set screw to grab onto, it's a much more secure mounting than bearing your set screw down on a round axle. And what I do, honestly, is I will file a flat down the entire length of my axle, not just where the set screws go, but along the entire length. And we're not talking I don't file off half the axle, but just a flat spot enough to where I have the freedom to move those collars in and out wherever I want, and then not have to worry about taking everything back apart and filing a flat wherever that set screw made contact. Does that make sense?
Yeah. So you don't want to do it too deep, though.
No. Like I said, don't file your flat halfway through your axle, but just enough, about the width of the face of the set screw is really all you need. Just enough of a flat spot to give that a nice flat surface for that screw to grab onto.
Well, the other thing too is if you go too deep with it, your set screw is not going to be setting too much inside of the wheel collar,
right?
Because they're not very long. So if you do it to where you have to tighten it too much or go in too far,
it's not going to have the threads.
Yeah, it's not going to have the threads inside of the collar anymore. So it might not even work for you.
Yeah, exactly. And speaking of threads, I'm not a huge fan of Loctite in general, but on set screws for wheel collars, I like to use Loctite.
The blue Loctite.
Yeah, the stuff that you can remove, whichever one it is.
The blue is removable.
Okay, so the blue.
The red is permanent.
Okay, don't use the red. Use the blue. Unless you never want to take it apart again, then use the red.
Nah, don't use the red. Just, you never know. I mean, you never know if you break a wheel, if you land too hard or something.
That's true.
Try and always make it removable.
But whatever you use some Loctite on those set screws, because they do vibrate loose. And, our airplanes, they do vibrate no matter how much care we take in balancing the propellers so that they don't vibrate. They still vibrate some.
They vibrate on landing. I mean, there's a lot of vibration that goes in through landings and takeoffs. Whew, a long night.
So use Loctite so they don't vibrate loose. And then one last thing, the axle, like I said, it can be either the bolt-on style, or if you have wire gear, the axle is sometimes bent as the final step as part of that. And so just a note about the bolt-on axles, they bolt on, obviously, but use Loctite on those too, on the nuts that hold those together.
Watch too. So if you're using the bent type landing gear to where you have it's not like a perfect bend where there's a little angle to it, your wheel can kind of walk up on that and get stuck.
Yeah.
So don't do that.
Yeah.
Use a spacer.
Use a wheel collar on the inside there to space it away from that bend so it doesn't get bound up. Yep.
Because that will lock up quickly.
Yeah.
Been there, done that one, I will admit.
Okay. I think I have too, actually.
Yeah, you learn by making mistakes. That's the easiest way to remember things.
These tips and tricks and my rules for setting up servos and all this stuff, those are learned through many years of failure, honestly. So let my failures
be your guide.
Be your guide, I guess. Yeah.
Well, that's a good way to do it. I mean, like I said, it's you make mistakes that you don't have to make if you have learned from somebody else.
absolutely true.
So
yeah, and hopefully saving you some money and time in the process.
And aggravation more than anything.
More than anything. Yeah, that's true.
Because, yeah, we don't want to get to the point where somebody wants to quit because they make a mistake that you could have saved them from.
Yeah, exactly. Yep. I could not have said it better myself. So next we'll talk about what I wanted to talk about, and that is the steps you take to get your retractable gear mounted and set up. Not an overly complicated process, and I'll preface this by saying,
but it kind of is an overly complicated process.
Well, I mean, if you think it through, well, I mean, it's certainly more work than putting fixed gear on your airplane.
Sure,
I'll give you that.
Okay,
but I mean, it's not really rocket science.
No, it's gear science.
Gear science, I like it. Okay. It's gear science. So you are a gear scientist by putting retractable gear. See, there you go. There's another reason to put retractable gear in your airplane. It makes you a scientist.
You can put that on your card.
On your AMA card. Just turn it over right on the back, gear scientist. At any rate, you start with the decision to put retractable gear in your airplane.
That's a good start.
That's a good start. Yep. So obviously we're not going to talk about this if you've decided to put fixed gear on it. So we're going to assume that you've decided to put retractable landing gear on your airplane. The next step would be to choose the type that you want to use. Either you want to use mechanical, pneumatic, or electric. There's pros and cons to all of those, all three of those. And the choice you make on the gear you use is going to depend on a lot of things. Your budget. It's going to depend on your skill level. Maybe you've only built a few airplanes, and maybe the setup is a little intimidating, which it can be. Maybe it's also going to depend on how patient you are, because especially with the mechanical setups, you have to be very patient and meticulous about your setup. So if you don't have a lot of patience, like me 20-ish years ago, then
or me today,
or Ron today. Are you 20? You're not 20 years younger than I am, are you?
No, but I'm just saying I'm to the point where I'm not all that patient right now.
Oh, okay. Yeah. Your choice will also depend on what level of detail you want to achieve. Like if you're building a master's competition class warbird,
Top Gun or something.
Yeah, then probably you're gonna choose the more expensive, maybe the more detail electric retracts with the scale struts and all that kind of stuff. And
to be honest, if you're building a Top Gun airplane, you're probably not listening to us talk about how to set up electric retracts or pneumatic retracts.
Absolutely true. Yeah, you're going to be the ones we call to get advice from. So,
hey, give me a hand with this.
Yeah. But anyway, those will be some of the factors that will sort of influence the choice you make as to which gear. But I'll start with the cheapest and most complicated, and we'll work up to the most expensive and least complicated.
Which is ironic.
Which is not ironic, because usually
that's right. That's not ironic.
You pay for convenience, right? Usually.
Which is the opposite of ironic. It's non-ironic.
So we'll start with mechanical retracts. That, like I said, they're the cheapest. They're the most inexpensive that you can buy, but they are definitely the most difficult, I'll say, to set up properly.
Finicky.
Absolutely, yeah. Everything has to be just right. The throws because they are mechanical and operated by a servo, like we mentioned in the last episode, the setup has to be just right for the gear to reach its up lock and down lock, and everything has to be, the moons have to align just perfect for everything to work perfectly on every flight. So
how many moons are there?
Well, there's like 5 or 6 around like Venus, right? Or something like that. I don't know. The moon and the stars. Okay, we'll just say it that way.
There we go.
Does that sound better? But anyway, to set them up, and this applies really to any retractable gear. The retractable gear is usually a unit that then is bolted into the airframe, in the wing or the fuselage. That mounting surface that you mount the gear to, the rails or the plate or whatever you're using, has to be completely flat. If you're using 2 beams, those beams have to be perfectly parallel. And the reason for that is when you put usually there's 4 screws that hold a retract unit in place. When you torque those 4 screws down, if there is any unevenness, it will cause the cage or the frame of that retract. Am I boring you?
Stop it. Just keep going.
It will cause the cage or the frame of that retract to actually twist or kind of
torque.
Yeah, in its mount, and that will cause binding. And binding is
bad.
Is the number one thing you want to avoid in your setup. If you can't avoid any of the other pitfalls, avoid binding, because that will for sure will cause a gear failure or a failure to extend, which means a belly up. A belly up
belly
landing. Thank you. Yeah. It's difficult for me to talk too. But anyway, we don't want that, especially on a warbird where maybe you've got some bombs and stuff hanging off the wing, and a belly landing would just tear the out of the bottom of your airplane. We don't want that. So avoid binding at all costs. So make sure those mounting plates or beams or whatever are perfectly flat, so that when you torque that gear unit down into the plate, it's nice and flat, and it swings through its rotation freely without any binding. And that applies to all types: mechanical, pneumatic, electric. You want them all to have a nice, flat, secure mounting, so that we're not torquing that cage or a frame and causing binding. So that's number one, and that applies, like I said, to all of them. Your gear cutouts. So I've seen this quite a few times in my years in the hobby. People will, they want that perfect fit, like when the gear retracts up into the wing and they've got the cutouts just the perfect size for the wheel, just to barely fit in there with no gaps or anything. That looks super clean, and it's awesome until they fly it the first time, because the gear legs are usually made of wire, and wire can bend, especially on rougher surfaces. So that perfect alignment that they had on the bench, now that they've flown it, they go to retract the gear, and the gear does this sort of thing and hangs up on the outside of the wing because they've made their cutouts too small. So do yourself a favor, make sure they fit the gear. Number one, make sure the gear will swing up in there and fit the cutout, but also make sure there's a little bit of clearance, because the gear wire can bend, especially on rougher fields. Like, our field can get rough in the middle of summer with the patchy grass that sometimes grows out there, and that will bend a small amount, the wire that your gear is made of. So, yes, take your time, make the fit nice, but also give yourself a little headroom on clearance so you don't have an issue when you go to try to extend the gear, but the gear is now stuck in the wheel well.
And that would be problematic too, because then you're stalling a servo.
Exactly. Yeah, so on a mechanical setup for sure.
Yeah. I thought that's what you're talking about was mechanical now.
Yeah. Well, I mean, the same rule applies. I mean, you want that cutout to be, have enough clearance for all of them, but especially with the mechanical one, because you're driving that with a servo. And now, like you said, you've stalled the servo, and now you're drawing all this amperage also through your system, taking that amperage away from the other servos that are controlling the airplane. So yeah, lots of bad things can happen, all because you wanted that perfect, nice fit. And I get it. I totally get it, but give yourself some headroom, make your cutout just a little bit bigger.
Give yourself some leeway.
Yeah. So that, like I said, it seems obvious that you need the cutout to fit the gear, but it's not that obvious. Give yourself some room. You will need when you choose mechanical retracts, you're going to need a servo to operate that gear. And the servos for retractable landing gear are specific for that purpose, because they swing through a 180-degree arc, as opposed to our standard aircraft servos, which I believe is 120 degrees. So a retract servo is unique in the fact that it rotates 180 degrees through its complete range. And that's important because that's how the uplocks and downlocks are actually accomplished on a mechanical setup. So you have to have that special retract servo, and that's how they're marketed. They're labeled high-tech.
Why is that, though? What's the difference between 180-degree servo rotation with a shorter arm versus 120-degree rotation with a longer arm?
Okay, well, I'll try to explain it. I mean, I know what the reason is, but I'll try to explain it. So when the gear is, let's say we have the gear retracted and locked, okay?
Okay.
You want that lock to be in line with the servo. so that if anything tries to pull that gear out, it can't because it's got no leverage arm because the rod is in a straight line with the gear. If you only go 120 degrees, you've got that angle now that you could actually physically push the gear out of the lock because your arm isn't locked in place. It's not like over-centered.
I guess I get what you're saying, but I always assumed the lock locked it. Like the lock locks that wheel to where it can't be pulled in or out no matter how
it does.
inline it is.
It is a detent in the framework of the gear unit.
Yeah.
But it only works in concert with that inline sort of arrangement of the actual push rod and the push rod mechanism of the gear.
So that's more important to be locked down than it is to be locked up.
Yes.
So why can't you just set it up with a regular servo to where it's locked down?
You could, but then in a high G turn or whatever like that, the gear may try to pull out of the wheel well, and then you're adding all this extra strain to the servo because now the servo is trying to keep that gear pulled up because you haven't got the 180 degrees. You've got the full lock on one end, but then you're only 120 degrees out. Even though the detent might be in the lock position on the gear, the servo is not in that. The rod isn't in the over-centered lock position, so you still got that tension on it. So as the gear tries to come out, it's pulling on the servo, which is now using more amperes to try to keep that gear pulled up into the same as like trying to deflect a rudder, when the radio is turned on by hand.
Okay. I don't necessarily I'll go along with you on that.
Okay. I probably haven't done a great job of explaining it, but there is a specific reason, and it has to do. I wish I had a mechanical setup here. Maybe I could show you, but it has to do with that 180 degree up and down lock action. Like, and if it's not in line, then you still, it's in the lock in the gear, but just the gear still depends on that inline sort of arrangement, so that the servo, it can't deflect the servo one direction or the other. But anyway, without getting really into that,
sounds more like a marketing ploy to me.
It maybe
for the 180 degree servo manufacturers.
Well, it worked on me. So
no,
I only buy retract
sense.
servos for retract applications. So anyway, you'll need a servo, and it'll be specific for the purpose. Now, if you're using tricycle gear, there's a good chance the one servo is probably not going to operate all three gear. Maybe you're a whiz at pushrod setup. I've never been able to get a tri-gear setup to work with one servo, and I've tried. So you may need a second servo to operate that nose gear on a trike gear, which actually simplifies the installation a little bit anyway. So, but anyway, mechanical setups, you're going to need a retract-specific servo, and you'll only need one for tail draggers. So then you will need. So now
you can use two though.
Two what?
Two servos for a tail dragger.
You can,
I mean, you don't have to.
No, you don't have to use just one. You can certainly use a
single one
each
per
one. Sure,
and that might, depending on the wingspan, depending on what you're doing, might be easier anyway.
Absolutely true.
Yeah.
Because you don't want your push rods to be really, really, really long, because then that potentially introduces flex into the system, which again sort of defeats the purpose of that locking mechanism.
Not just the locking mechanism, but it's amazing how much pressure it takes really to push a servo up or down. Or not a servo, but how much pressure it takes from the servo to push the gear up and down.
Yeah.
So
that's true.
That you don't want flex in that because of that.
Yeah. So anyway, you could certainly use one servo for each gear. There's no law against that, and that would definitely simplify your setup and probably actually make it work better, because then you have individual control of each gear. But at any rate, so now that you've got the gear and the servo, you need to connect the two together with a push rod. Just like you would connect a push rod to your control surface, you can think of the mechanical retract gear, as a control surface that needs actuation from a servo. So you have to have some sort of a push rod to do that. And you want that. Here's a few things about the push rod. You want it to be as straight as possible, like no bends or anything like that, because we don't want to introduce any flex. And that push rod, the longer it is, the more support it needs along its length. And you can do that lots of different ways. You can, the rod in a tube type arrangement, you can set that up. You can fabricate standoffs with bushings in them to help support that rod. Any way you can support that length of push rod will do good things for the operation of the gear. The more solid that push rod installation is, the more solid the actuation will be. Again, all kind of plays into the complexity of setting up mechanical retracts, but they are the cheapest, unfortunately. For me personally, the way I set mine up, usually I try to only do retracts on tail draggers. The Duelist was an exception, but with mechanical retracts anyway, I don't even want to mess with the nose gear because
the steering.
And
the steering is the biggest thing.
Yeah, and I'll talk about that in a little bit. But yeah, when that gear starts retracting up, you got to have some mechanism in place to center the wheel so that it retracts straight up in there. You don't want a wheel cock sideways as you're trying to retract it, then it's stuck on the outside of the edge. Just so many factors. So I try to avoid retractable nose gear at all costs. But I got it to work okay on the Duelist, and it's been flight tested, so my setup works. But I try to avoid that whenever possible. So on a mechanical setup, I usually operate my gear with just one servo. And I do that, which was two push rods because there's two gears. Two gear. Is it gears or gear?
Two landing gear. I don't know.
Two retractable gear units. So there's one push rod that has to go to each. And I actuate that off of one servo. And the way I do that is I just use a two-sided servo arm, so it just looks like a straight line. So there's one arm on one side of the output shaft, and then 180 degrees, there's another arm. And I use, and man, I hate to admit this, but I use easy connectors. I know. I use easy connectors at the servo end. And I use 440 rod because it's a bit thicker and stronger and less flex. And then I'll run that out to my gear, and then I have threaded ends at the gear end, and I use metal clevises to actually snap that onto the control rod, or I'm not sure what that input rod, I think is what it's called, maybe but there's a rod on the mechanical gear that actually moves in and out,
slides in and out,
that you have to actuate. And that's how I set up. And the reason I use easy connectors, I know I've said on the show before that I hate them, and I do. But the reason I use them on this is because
they're easy.
It takes a lot of trial and error to get that
throw,
to get the throw just right, and to get the angle just right, and you're doing 180 degrees, so you don't want anything kind of interfering with each other. So it takes a little bit of trial and error, and the easy connectors just make it unfortunately easy. But I use Loctite on the bolt. When I finally get everything the way I want it, I use Loctite on the bolt, and I file a small flat on the actual rod where the set screw bears down, just like I would do on an axle, to try to give me that feel-good feeling that that's not ever going to come apart. So,
I get it.
So on landing gear, I will give myself a pass, and I will use easy connectors on the landing gear. Retractable landing gear servo, I should be specific.
Hey, I'm not judging you.
But anyway, once that is complete, once you've got everything hooked up and you've got your gear cutouts just right and the gear, cycling, test it thoroughly. I mean, like really put it to the test in the workbench or on your workbench, because time spent here getting it just right is going to save you a lot of aggravation at the field if you have to do, like I said, if you have to do like a gear up landing with, stuff hanging off the bottom, but you don't want to tear up your monocoat and all that kind of stuff. So
test over and over
all
again.
That work you do now will save you lots of headaches later.
Okay. Let's move on to pneumatics.
Yeah. So pneumatic, that's the next sort of tier as far as expense is concerned. However, they're more expensive than mechanical, but they're a little bit less work to set up. They're actually easier to set up. I'm gonna go ahead and say it.
But there's more to do.
Yeah, and I failed to mention this when we were talking about the mechanical ones, but usually, not always, but usually when you buy a set of retractable landing gear, it will come with this thing inside the package, and it's called the instructions.
We don't need those.
I would read them. Actually, there's a lot of good information on there, but yeah, read the instructions. Do yourself a favor. Sometimes there's unique requirements to a particular brand of gear that I probably haven't mentioned here. So read the instructions, and usually you can't go wrong when you do that.
When in doubt, just read the instructions.
Just read the instructions. Yeah, isn't that the name of what's her face's?
That's why
ship?
I said it.
Okay.
Yeah. SpaceX's drone landing ship.
So yeah,
I'm a dork.
No, that's okay. That's cool. So pneumatic retracts, you have to have the same sort of what am I trying to say?
I don't know. You just spaced out.
I did.
Same sort of.
They have similar requirements as mechanical retracts and electric for that matter. The mounting needs to be solid and flat, just like I mentioned with the mechanical. We don't want to warp that cage or get it, sort of askew in the mounting, causing binding, because we don't want any binding. And your gear cutouts. Again, give yourself a little bit of headroom with the room to just in case the wire bends on a takeoff or a rough landing and you don't catch it before the next flight. So, with those requirements out of the way, the stuff that sort of sets pneumatic apart from the others is that it's operated by air, pressurized air.
Well, and that's that then, right? I mean,
it doesn't require a specific retract gear servo. It can use any old standard, analog or digital airplane servo, which is great because then you can use a small, lightweight to read cheap servo to actuate the air valve that actually works.
You're worried about a cheap servo for expensive retracts.
Well, I mean,
they're pricey.
Well, some of them can be, yeah. They're certainly more expensive than mechanical retracts, but
and there's a lot more plumbing that goes into them.
There is, but as far as the actual air valve itself goes, it's actually quite easy to move back and forth. It's just I think the technical term is a shuttle valve. It shuttles high pressure air from one side to the other. But anyway, it's actually quite easy to move. So a relatively inexpensive servo, usually it's not too much for a servo like that to handle. Myself, as I've mentioned before, I think in the servo episode, I really, really like those high-tech 225 MGs, I think is what they're not terribly expensive, relatively speaking. They're not terribly expensive,
what they are.
But they're a great quality servo and they're lightweight. That's what I like about them. And they're small, so you can fit them in small areas. In fact, if you look at the Duelist build videos or the build log on the website, you can probably actually see where I stuck that servo, and it's, like I said, it's in a really, really small space, and it does the job perfect. But anyway, you don't have to have a fancy retract-specific servo. This is what I'm trying to get at. A standard aircraft servo will work just fine.
Well, not standard size. You mean like...
Well, a standard size will work, but just a standard aircraft servo. Yeah.
Smaller one.
Yeah.
Okay.
A regular aircraft servo that operates...
Not a regular one. No, I'm kidding.
So you don't need a fancy retract servo. You can use any other type of servo.
Continue on. Okay. I gotcha.
Just wanted to make sure
that we're good.
All right. And then, the only other thing, once you've got the mounting done and you've got the servo figured out and you've got the linkage set up so that you get the full travel on your retract valve, the only thing you have to worry about then is the plumbing. It's super, super easy to do. But it is a little bit more work than an electric retract where all you have to worry about is basically a servo lead.
So are those kind of like, is that air up, air down?
So yep.
Oh.
Go ahead. No, you've got it.
Okay. So are those air up, air down, or are they spring loaded one way?
So there's both types. The type that I put in the Duelist are
I think you've told me this before, but I don't remember.
Yeah, maybe. I don't remember either. But the type that I put in the Duelist are air up and air down. So it uses pressurized air to go both up and down. There's other types of gear on the market that are air up, and then for safety's sake, they spring down. So if you have a loss of air pressure on board, the gear will naturally spring down.
Or if you just run out of air.
Or if you run out of air.
That's a good idea, actually.
Yeah.
I prefer it defaults to down.
Mm-hmm. Yep. It's been my experience that the spring down retracts are a little bit heavier because of that big internal spring that's, kind of
springing it down.
Yeah, exactly.
Yeah.
But yeah, they work great. Yeah, there's been several companies over the years that have made them spring air. That was their, I think they were known for that, not only by the name of the company, Spring Air, because they spring down.
Quite exact.
Yeah, but I think Robart actually either bought the company or maybe they bought the rights to produce the gear. But Robart produces, or they did produce, the spring down gear also. But anyway, that's the two different types of pneumatic. But yeah, just a couple notes about running the airline. It is flexible. So the tubing, it's a really, really thick, I'm not even sure what it's made of. It's some sort of a rubberized neoprene, something. Comes in several different colors, but it's a really, really thick wall. But it is flexible. So you can route it, kind of wherever you need to route it. But do yourself a favor, and which is common practice that I see, and I'm guilty of it too, just running the line in there, laying it in the fuselage, and then just expecting it to stay where you put it. I mean, it is flexible, so it is designed to be routed, around corners and things like that. But don't just leave it laying in there. Try to fabricate something to hold the tubing in place once you've got it where you want it, because the last thing you want is for that tubing to come loose and then get wrapped around a push rod or something like that. So, yeah. Aside from that, there's really no. I mean, they either go all the way up or they go all the way down. There is no mechanical linkage that you have to set up or anything like that. So they are quite easy to install. So,
what kind of pressures do those work at?
Yeah. So on mine, I think my little Robart gauge at the end of my pump goes up to 120 psi. I think
it's about standard for an air compressor.
Okay, and I run it up to there, and I can get probably. I don't have a huge tank in my airplane. I think it's I want to say it's an 8-ounce tank, I think, air tank. And I can get easily 12, 13 cycles. And that's 3 gear now, a nose gear and, the 2 mains. So, I mean, one charge at 120 PSI will last usually almost an entire day's, flying session. So a couple of things I do is I guess there is one more step. You have to figure out where you want to mount the fill valve, because there's going to be a valve that has a one-way, kind of like an air chuck that you'll plug your pump into to pump up the system. So most often I just create a little light ply hard point in the fuselage to mount my valve, and just mount it right to the outside. And usually right next to it, I will mount one of those Robart number 173 air gauge. It's a cool little deal that if you mount it right next to the chuck, the more you air it up, the more this little valve sort of sticks out of the gauge, and it has little
colors.
Yeah.
Markings
on it, yeah. Segments that kind of tells you, I think it's in 5 PSI increments. Oh, no, I take that back. It's in 10 PSI increments. And it'd give you a quick indication of how much pressure you have left in the thing.
Oh, okay.
Yeah, it's kind of a neat little
I thought
gizmo.
Maybe it was red, green, and white, or red, green, and yellow.
The lines I think the lines are like they have red on them to make them easier to see.
Okay.
Yeah, because they're just basically, it's an aluminum shaft with these lines sort of machined into it. And the more of those you have sticking out, the more air you have in the system. So, but if you're wanting to hide something like that, if you don't want your fill valve exposed or viewable, you can, you could put it on the inside of the airframe somewhere, like maybe before you mount the wing.
Or under a hatch,
under
a canopy maybe.
Yep. Or if it's, if you want to get really, really kind of scale, you could create a panel somewhere and build a little compartment and put it in there. And which would also be a good place to stash a thing like, like your switches or charging jacks or,
anything.
Arming switch for an ESC or whatever. That's another topic. Getting into a different world there. But yeah, so that pretty much covers the pneumatic retracts. A little bit more money. Yeah, they're a little bit more expensive. Okay, they're a lot more expensive than mechanical retracts, but they're so much easier to set up. They really are.
Now, when you're running the hoses and stuff, is it just press fittings, or do you have I mean, like what holds it on? Is it a barbed fitting that goes in? I mean, like, are there tiny, what are those things called? The little,
hose clamp.
are there like tiny hose clamps or anything or what?
No. So, well, yes and no. So all of the fittings that the tubing goes onto, those are all barbed.
Okay.
So they have barbs on them to prevent pulling them out. And let me tell you, it takes a lot of pressure to pull one of those things off of those barbed fittings. But if that's not enough, Robart in their kits, I think they include them, and they also make them available for sale. It's a knurled nut that has threads on the inside that you put that on the piece of tubing, and then you put your tubing over the fitting, and then this nut slides over and kind of threads over the fitting and sort of clamps.
Almost like a compression type fitting?
Exactly. Thank you. Exactly. Yeah. So,
cool.
Yeah, I think I use those on my tank and my fill valve, but everything else is just pushed together with those barb fittings. And knock on wood, I haven't had any come loose yet.
That'd scare me. Like, I don't know why, but just no mechanical fastener on there would scare me.
Well, I mean, your fears would be put at ease when you try to pull that hose off of one of those fittings just one time. I'm telling you, they are really hard to get off.
Yeah, I guess. Because as you pull, you're making it a little bit smaller, so it's holding on more.
Yeah.
I gotcha.
Yeah.
Okay.
So yeah, that's Pneumatic. Don't be afraid of them. They're pretty easy to set up. Just a few, gotchas there that you have to be careful of.
But then you got to buy a pump too.
Yep. There's the added expense of a pump, and then the valve. Oh, and that was something else I wanted to mention. Do yourself a favor. If you're going to go the pneumatic route, buy the valve that has the regulators built in. I know Robart sells several different styles of valves, and the one I'm talking about is the red one. I don't have the part number off the top of my head, but it looks like it has two little chimneys on it with some thumb screws on it. And what those do is those allow you to change essentially the speed at which the gear actually operates. So essentially you're allowing more air to bypass during that cycle. So you're not slamming that gear at full pressure up into the wing.
Oh yeah, I didn't think of that. If that went fast, that could be bad.
Yeah, I mean there are stops built into the gear cages to obviously stop the gear from traveling any further. But the momentum, especially for heavier gear with like big tires or whatever on them, that momentum when it slams up there, they may go because of the flex in the wire or the struts or whatever you're using, may allow those to go a little bit farther than you intend them to,
and slap your wing
and slap the wing or knock a nose off. I mean, vibration is our enemy, and we want to try to prevent as much of that as possible. And another way to prevent vibration is to not allow that gear to just slam up or down even.
Yeah.
Because then, with the gear coming down with that momentum, it's going to be wear and tear on the blocks that the gear is mounted to.
Oh, yeah.
So do yourself a favor. Spend the extra money you're already buying pneumatic retracts anyway. Spend the extra money and get that valve with the proportioning valves built in. That way you don't have to use those inline flow restrictor deals. You know what I'm talking about? You've seen those. Those things, they work.
For other things, but I know what you mean.
Yeah, they work, but
it's another failure point.
They don't work as slick as being able to fine tune the speed of that gear. And I use it on my Duelist, and the Duelist is, by all counts, a relatively low cost airplane to put a high dollar retract system in. But
I guess still pricey though.
It was worth it to spend the money on that valve because, like I said, I can control how fast or slow that gears goes, and I can prevent it from just slamming into the airframe. So there you go, pneumatic retracts.
Good deal. Lastly,
the most expensive. When you compare similar sizes, the most expensive and the easiest by far to install and set up is the electric retracts.
Now you have these on your P40.
I do, and they rotate even, which is even cooler.
And how much were those?
Okay, so it goes back a while, right? We've had the P40s for a while, and I bought the retracts when I bought the P40, and I don't think I got a discount. We got a discount on the P40s.
Yeah.
But I did not get a discount on the gear, and I believe I paid, these were the E-Flight ones for that airplane, and I want to say I paid $189, and this would be back in what, 2012-ish? 2000.
No, it was 2013. I think is when we got those.
Okay.
Yeah. So the kit, the whole airplane, was $99, and then your wheels.
The gear didn't come with wheels. It was just the gear.
It didn't even come with the wheels.
No.
Anyway.
Yeah. So, but man, I'm telling you what, the installation was so easy.
Yeah.
I mean, the same rules apply, right?
Mm-hmm.
You want a nice square flat surface to mount them, and you want your gear cutouts to be a little bigger than your gear, which was all taken care of for me on the P40. Like,
it was an ARF. Yeah,
it was an ARF. But yeah, so I didn't have to worry about any of that because it was all done for me. I mean, I checked the flatness and it was fine. But yeah, all I had to do was take the gear out of the package. I think I may have had to cut the wire and mount the axle because I think it had like a weird L-shaped axle thing that slid over the gear strut, and then you had to set screw it, or I don't know, some weird thing like that.
Yeah.
But anyway, mount it into the airplane, plug it into a Y harness, and plug it into the retract channel of the receiver, and it was done. Like, that was it. That was the whole setup.
Yeah, there's no adjustments. Yeah. There's nothing.
Tested it a few times on the bench, and there was no adjusting anything. There was no having to route rubber tubing anywhere. I didn't have to mount a tank. I didn't have to mount a valve. I didn't even have to install an extra servo. Like, I mean, it was...
there's nothing to them.
They're really the simplest setup of all of them. But they are the most spendy, unfortunately. So here's some, like, so there's my steps, you know, that from the most complicated, least expensive to the most expensive and least complicated. Then some general tips for installing retractable landing gear before we finish is the goal of every setup is to minimize any binding. You want your gear to swing freely. And you can test that by disconnecting, in the case of a mechanical, by disconnecting the servo and operating that control rod manually and testing the gear that way to check for binding. On a pneumatic system, it's a little more complicated than that, especially if it's a spring down type. But basically, remove all of the air and physically manipulate. You can usually do that with a strategically located screwdriver to unlock and then move that gear by hand just to make sure there's no binding. And on the electric setup, if you're up for the challenge, you can actually physically remove the electric motor portion of the gear completely away from the retract and move the retract by hand again to check for binding. But on an electric retract, it's probably tested at the factory, so there's not going to be any binding as long as you haven't introduced any with the mounting. But anyway, the goal in your setup should be minimize binding wherever possible to make that operation as smooth as possible to take care of anything that, if you're using a servo to operate it, you don't want that servo to have to overwork itself, things like that. So that should be your first goal. Again, like I said before, you want your gear mounted on a nice, flat, completely flat surface. We don't want to tweak that cage or the gear frame in any way because, binding.
It's all about the binding.
It's all about the binding.
All about preventing it.
It really is. I mean, mechanical retracts, just know that any extra deflection of that control rod is going to take away from the authority it has on the gear. So you want that push rod that goes from the servo to the mechanical gear to be well supported against any kind of flex or anything like that. That's something to look out for on mechanical ones. On the pneumatic types, like I mentioned, there's several different valves you can use that are out there. Do yourself a favor. Spend the extra money on that Robart. It's red in color. I don't know the number. I apologize, but it has variable controls on it that you can control the rate of the movement, the speed of the movement of that gear, because you don't want it, slamming into the airframe. And electric retracts are the bomb. I mean, if I could afford them, I would have electrics probably, aside from the Duelist, I would have them in every airplane I have that has retracts, just because they're so easy to work with, and they're nice because you can actually, like a servo, you can speed them up and slow them down if you have that function on your transmitter, which is kind of cool. I think.
I agree.
you can, like in the case of my P40, they go up really, really, really slow.
Really scale-like.
Yeah, which looks cool. So, and that's really it. That's really all I had to say about it. Just the number one rule is try to eliminate binding wherever possible, and
no binding,
and test your setup on the bench, like thoroughly test it on the bench
at different angles too. By the way, lift your airplane up or put it on an airplane stand at different angles: 45 degrees, 180 degrees, upside down, right side up, left, right.
Yep,
check it.
Absolutely,
nose up, nose down.
Yep. Check it in every conceivable angle. Yeah.
That's when you want to find the problem.
Exactly. You don't want to find it on your maiden flight. That's for sure.
All right. Well, anything else?
No, I think I've blathered on about retractable landing gear long enough.
I agree. So,
hey, fill out those surveys.
Yeah, please do. Until next week, I'm Ron.
I'm Tom.
Good night.
Good night.